Let me do this. All right, where you got? Where you at?
And we could try 9.5. So number one has the HO with the mu equals, and then HA with the mu is less than. I thought it was supposed to be opposite of
Which
like
one are we looking at?
49.
49. Okay, let me see. Oh yeah. Okay. So I'm pretty sure I said this the other day. This book is kind of funny. It's not consistent. There are schools of thought that say HO should always be equal to. I am not a member of that school of thought. I agree with number 50. Do you see how they kind of go back and forth between? I don't know. So, yeah, just overlook this. It doesn't matter because what sets up where the tail or tails are?
Uh,
Which statement, HO or HA?
um, oh, because it's in
Nope.
the. Oh, I don't know, man.
I think, well, based on what I think you're about to say, you're kind of looking at it backwards. Like right here, read through this. Where would the tail be? Which statement are you going to look at to see where the tail is going to be? All right, let me ask. What statement can we show evidence for? Which statement?
HO.
No, never. That's the whole thing. I can never use a sample to show evidence of something equaling something, right? So if I took a sample and I got a sample mean of 10, is that evidence that the actual mean is 10? No.
Because it
Could
equals.
it be evidence that the actual mean is less than 80?
Yeah.
Yeah, because 10, that sounds like it could be evidence that it's less than 80. So I
Right.
can only show evidence for strict inequalities. I can only find a sample that's so far up or down to show evidence for greater or less than. Is everybody with me? So it's the it's the alternate hypothesis. That's the one that sets up where the rejection region will be, because that's the one that I can actually show evidence for. So on one level, it almost doesn't matter what this guy says. But technically, I agree. It should be the opposite of this guy. So they wrote 50 correctly, and they wrote 49 the other way. I don't know.
Reject the hoe, support the huh?
Is that your slogan? Is that
Maybe
yeah?
now.
Garcia 2024. Reject the hoe, support the ha. All right. But I mean, the question is it a left tail, right tail, or two tail test? So if you look at this, you can clearly see where the tail is going to be. Is that right? I mean, is that correct? Can you tell where the tail is going to be if you look at HA?
Left.
Yeah, it's going to be on the left side. To show that something is less than 9, my sample's got to show up way down on the left side from the mean. Is that no? You don't like that? Okay. Let me draw this out.
I made it easier for me to look at the sign, like where they go, like where's the
Exactly.
greater and
Little
less
arrow.
than.
Exactly.
that's what I was
Yeah, and the equal sign for like if it's like two tails or not equal.
Sure. So I mean, as always, inequality symbols, you can treat them as arrows. So less than means it's going to be on this side, because the sample would have to show up in here to show that the mean looks to be actually less than 9. So there's going to be a left tail test. Yes. Which one of these will be a two tail test?
51.
Yes.
Yeah.
Yeah, that'll be a two tail test, because not equal to means up or down, means greater or less.
I have a question.
Yes.
So why is it for 49 that the ho has an equal sign, but the ha has the inequality sign?
So we just talked about that. There is a school of thought amongst mathematicians, statisticians, that the HO should always have just an equal sign. That is a small group. A larger group says it should be the opposite statement from the ha, because that makes more sense. So for some reason, this book decided to use both ways of thinking about things. Why does that not affect the test itself? Because again, it's the ha, it's this statement that sets up where the rejection region is going to be. That's where everything happens. Does that make any sense?
No, it does now. Yeah, thank you.
Okay, you're welcome. So yeah, I think it's kind of funny that the book sort of went, let's just do both. All right, book, way to pick a way. Okay.
The book is neutral.
Well, it's kind of like the opposite of neutral, but I don't know. We're Switzerland, but we're picking both sides. All right, whatever, book. Anything else, guys, from homework stuff?
For number 74, should we use the process we did for the question we did with you?
I don't know. Let's see. Oh, yes, please, dear God. Thank you for reminding me. I got to remember, this book has these weird ass solution sheet bullshit. Now, do not use the worksheet they have that shows use the 5 steps we talked about.
Okay. Good.
They actually are the same steps. They just are in different order because the book uses the calculator too much.
It's more like even they are using the, the confidence like 95% or like that. It's more things.
There's more things. I agree. And it's out of order. So it's
Yeah.
yes. Please don't. I got to remember that because there's another place coming up where they say the similar thing. And I got to remember to say, don't look at that. Don't worry about it. Okay. Everybody with me? So when you're doing section 9.5 homework, when you do these problems, you do the 5 steps we did. What are the 5 steps? Look at the worksheets. I got a ton of worksheets. And guess what? Aren't the 5 steps always the same? Yes. Okay. So that's a good question. Thank you. I always forget about that. Anybody else? Anything? What does this look like? Yeah, it's disgusting. Go away. Okay. Any other questions? Does that mean everything's going okay? I think I've graded everything that has been turned in for chapter 9 so far, which is not a boast because it's not much. So keep on working. So if there's no other questions, we're going to get right back into things. There's 2 things we got to do to finish up chapter 9. We got to talk about types of error, type 1 and type 2 error. And we got to talk about hypothesis tests for percentages. And then we'll be done with chapter 9. Dude. Okay. So let me turn off Bryce Canyon behind me. Where'd you go? There you are. Ooh. Come on. There you go. Oh, yeah. I got this dude. Oh, you can't see him. He's the math panda. Sorry. Bam. Oh, well, let's see. How messy is my house? It's not that bad, I guess. All right. So the first thing we're going to do is we're going to look at types of error. Let's see. And when I say type of error, as a student, can you make mistakes? Well, as a teacher, can I make mistakes? Shit, yeah. But in statistics, when we say error, it's not like we did something wrong. It's the uncertainty of things, right? Get out of here. All right. So let me see. Can somebody tell me how many possible outcomes are there to a hypothesis test? How many outcomes are possible for a hypothesis test? Hypothesis.
2.
Beautiful. I love it. 2. Yes. What are those?
Guilty and not guilty.
I like it. So either H naught is guilty of being true, or H naught is not guilty of being true. I like it. So let's put it into a little more technical language. Either we can reject the null, or we can fail to reject the null, correct? Now, if I reject the null, another way to say that is I support the ha. Those are the same thing, right? Those mean the same thing. All right, so that's why some people say there's 4. There's only 2. Either reject the null or support or fail to reject the null. So one outcome is I reject the null hypothesis. And the other one is fail to reject. Now, the crazy thing about statistics in real life is we often don't know what the right answer is. Is there a chance that we're wrong when we get an answer? Even if we do the whole thing right, if we do every step perfect, is there a chance that our conclusion is wrong? Hell yeah. That's the whole name of the game with statistics, right? Statistics is like, this looks to be about here. You know? So there's always a chance we're wrong. That's where this word error comes from. It doesn't mean you did something wrong. It just means there's always a chance that the evidence is actually not enough, or the reality doesn't match what we see. Okay, maybe. I don't know. All right. So if I reject the null, what kind of error could I make? We're going to call it a type 1 error. When would this be a bad thing to do? Because tell me this, in reality, what could be true? In reality, the null could be true, or the null could be false. That's reality. When would this be a bad thing to do? Which one of those two situations would it be bad to reject what the null is saying? If the null is actually what? You could do it. If I say, you're wrong, null, you're wrong. When is that a bad thing? If the null is actually
Right.
right, when the null is right and I think and I reject it, isn't that bad? Does that mean we did something wrong? No. It's just because that's freaking life. What's up? Somebody unmuted you, okay? All right. All right. So a type 1 error is when we reject a true null. Let me see if I can push this one just a little bit. All right. So let's pretend like I have a one-tailed test. And if I get a sample here, that would reject the null, correct? You guys with me so far? If that was the situation, and that's our Z star, we would reject the null, correct? I really want you guys with me. Come on. All right. Where's alpha in that picture?
To the right, shaded area.
Yeah, this is alpha. Is that just me? I thought I heard whistling. I don't know. That shaded part is alpha. Now, this is huge. This is all part of this. Just because the sample is here does not mean this mean is wrong. In fact, there is an alpha chance. Like if alpha is 0.01, that's a 1% chance. So let's say alpha is 0.01. There is a 1% chance that a sample would show up in there. Is that cool? Because, right? 1%. Sorry, go ahead.
Oh, sorry. Can you show us where the p-value is again?
P-value would just be the area below this.
Oh, okay.
That's all.
I see.
Yeah. Now,
Sorry.
that's right. So here's another reason why we might want to make alpha smaller, is because it is the probability of making a type 1 error. I really want you guys to get this. There is a 1% chance that we pick a sample that is here. So there's a 1% chance that we'll end up rejecting a null that's true. So if somebody's like, I think the average age is 20, and we take a sample and we get an average age of 50, and we're like, it looks like you're full of shit. And what turns out is I just happened to pick a bunch of old people. There's like a 1% chance of me doing that, and I did it. It could happen, right? You guys kind of with me? That's exactly what I'm talking about. So I made a mistake. I'm going to have to go back and say, I'm sorry. You're full of shit.
I was right.
Go ahead. What's that? Oh, look at that.
No, I just said that the hoe was right.
You got a Spock here. All right. Okay. All right. Let me think. Where was I? So again, why would you possibly want to make alpha smaller if a type 1 error is bad? If a type 1 error is bad, worse than a type 2 error, then you want to make alpha small, because alpha is the probability that you're going to make a type 1 error. A little asterisk, it's not exactly that, but it's close enough to that to discuss. All right. Just want to throw that at you. Okay. So a type 1 error is rejecting a null that's actually true. Reject a true null. Okay. So what should the type 2 error be? When is it bad to do this? When do you want to reject a null if the null is
Wrong or
wrong, false?
Right.
Right? So when is it bad to fail to reject it? If I fail to reject a false null. So type 1 error. When do I not want to reject the null if it's true? So that's an error. When do I want to reject a null? When it's false. So this would be an error, failing to reject it when it's false. All right, it's not quite as clean as this. There is a probability of this, and it's called beta, which should kind of make sense, alpha beta. It is a little more difficult to calculate what that is. But it kind of makes sense. If alpha goes down, beta goes up. But they're not perfectly opposite or something. You guys just don't even worry about that. It's very freaky. So let's do some specific examples, right? Now that I've explained what these errors are, let's do some specific examples. I'm going to erase all this. You ready? All right, I'm going to take that as a yes. Okay. I like to do my first example, have it be not mathematical. Let's say you're a medic in a battlefield. On a battlefield? In a battlefield? I guess you'd be on the battlefield. Whatever, Jeff. That's why you don't teach English. And you're running around, and you're coming up to people that are laying on the ground. And you want to help people that you can help. So what are you checking for when you come up to a person laying on the ground?
If they're
Why they're
alive.
laying on the ground?
What? All right, Nikisha, what'd you say?
If they're alive.
If they're alive, cool. And Ethan, what'd you say?
Why they're on the ground?
Okay, why they're on the ground. Yeah, they could just be, I'm just relaxing. I just needed a break. This is intense. And I'm like, okay, great. That's fantastic. Let me go to the next one. All right. And Nikisha's saying, all right, you run up to somebody, they don't say, I'm just relaxing. They don't say anything to you. You want to see if they're alive, right? Because if they're alive, what are you going to try to do? Help them. If they're dead and you're in a battlefield, what are you unfortunately probably going to have to do?
Go to the next person.
Go to the next one. I love it. So let's see. What do you think your null hypothesis would be in this case. It's not mathematical. It's English. They'll try to make mu or p or something. This is interesting. What are you looking for evidence of when you come up to a person? What are you trying to find evidence of? If you found somebody laying on the ground and you want to see if they're alive, what are you going to check for?
Pulse.
Pulse. I love it. A pulse. Or even if you have a little mirror, you can put it next to the nose and see if they're breathing, right?
Heartbeat.
Heartbeat. All right, so you check for pulse. So this should be a person is alive, because that's what you're looking for evidence of. You're trying to fight against the idea that they are person is muerte.
So what would the claim in this be?
The claim is the person's alive, right? Does that make sense?
Oh, okay.
Because you're the medic. You're going to go out there. You would not go out there if your claim is they're dead. They're all dead. I'm just going to sit back and relax. I got nothing to do because they're all dead. Look at them all. They're laying out there. They're dead. No, so that would be bad. And I'm sorry to be talking so flippantly about dead people, but hopefully you're okay. I watch too much Game of Thrones. I'm desensitized to everything. Especially season 8 desensitized me to life in general. But if you watch season 8, you know what I'm talking about.
Yes.
Yeah. So what would a type 1 error be? Remind me, what's the type 1 error? It's when you do what to what?
Reject the help.
Reject a
True.
true null. That's what makes it an error. So I always remember it this way. The smaller phrase is type 1. Reject a true null. The longer phrase is type 2. Fail to reject a false null. So type 1 error is I reject H naught, but H naught is true. So what does that mean in the language of the situation?
I thought they were dead, but they not.
But careful. I reject H naught. So what do I think?
Oh, I thought they were
but they're
alive.
actually
I
dead.
think they're alive,
Yeah, but they're actually dead.
but actually they're dead. So why would that be bad?
Because you're wasting your time.
Yeah.
Wasted my time. Exactly. Good. I start to try to revive them and they're dead, right? And I don't have all the equipment to like bring them back to life. That could happen in a hospital, right? But I'm on the freaking battlefield. I can only do something for somebody still around. Maybe. I don't know.
Plus, you're showing the length of the other person being at risk.
There you go. So what would a type 2 error be? So start with it. What it is in general. I failed to reject the null, but the null is false. So this is type 1 error here. So what would a type 2 error be? I failed to reject this. So I actually think what?
I think the person's alive, but they're actually dead.
Yeah. Wait a minute. We failed to. Oh, I'm sorry. I'm being silly. You gotta be
Oh,
careful.
wait, no, I just said the same
Failed to
thing.
reject the null. So I think I might have said this wrong a second ago. I'm sorry. We failed to reject this. So we actually think this is true because we failed to reject it. So we think they're dead, but they're actually alive. Nah. Okay, pretend like this is alive. Why would this be bad?
I would just let the
Probably
person alive.
die.
Yeah, they're alive. I come up to them and they're like, "Oh, good, he's here." And then I'm like, "Oh, this guy's dead." And I kind of start running away, and they're like, "What? No!" All right, again, I'm sorry. Please, I have a dark sense of humor, so I'm sorry if that's traumatizing. But all right. I don't know if this helps. Let's do one that's more mathematical, right? Because that's more going to be in line with what they want in the homework. Okay, but I like this example because it's not math. You can actually consider the implications of the errors. Does somebody have an idea of which error is worse?
Probably type 2.
Yeah, type 2 does seem like a little bit worse. I mean, they're both bad, correct? Type 2 is a little worse because not only are you, I don't know, to me it's worse from both perspectives. It's obviously bad for the person that's actually alive and you leave them, right? But then if I find out later, I'm going to feel like shitty. Anyway, so it's really kind of a judgment call, but I think I agree that this is a little bit worse, even though here you're wasting time. Okay. Let's do one that's more mathematical. So we're talking about, let's say we're talking about average, who cares? Average what, Jeff? I don't know. Let's see. I can't think of an idea. Average, this is not going to be high stakes, so it's just too bad. Average length of movies, right? So we have, let's say the null hypothesis is it's less than or equal to 2 hours, and the alternate, gotta remember this book is an A, is more than 2 hours. Okay. So then what would a type 1 error be? Put in here, hours. So always start with what it is in general, right? So always start with type 1 error is when I do what? I
Rejected true how?
Yes. Sorry. I just love that so much. It's like such a weird visual. You rejected a true hope? So what does that mean then? We think what when in reality what? So we reject this. So we think what?
We think it's less than or equal to 2 hours, but it's actually longer.
Yeah, we think that the mean movie time is less than 2 hours when it's actually longer. All right, that's pretty boring compared to our battlefield medic, but too bad. I'm sorry. Did you say less than? So rejected true. So we think it's more than 2 hours when it's actually less. Right? The null is true. So this is a true statement. Or, I should say at most. So let's get this straight. So what is the null is true? Actually at most 2, because that's true. But we reject it, so we think it's greater than 2. We reject this guy, so we think this, but in reality this. What's a type 2 error? That's the longer statement.
It's at most 2 hours, but
Yes, all right. So we think what now?
it's at most 2 hours.
Good. We think it's at most 2 hours, but in actuality,
It's over 2, more than 2.
it's more than 2. All right. You see how this basically just switches it? I mean, I don't know. It's a dichotomy. It's one or the other. So it's kind of Not that difficult. You just got to have a way to remember which is which. All right, so not very exciting. I'm sorry. At least the medic on the battlefield was more interesting, but oh well. So there's a whole little section, and you have to write the types of errors for each thing, and it's basically always the same. Here, that is reality, we think this. Here, that is reality, we think this. Bam. Okay, maybe. Maybe? I don't know. All right, I'm going to erase all this. All right. Now, the next big thing is the last type of hypothesis test in chapter 9 is percentages. So the funny thing is hypothesis test for proportions, which I'll call it that for the book. But really another way to say it is percentages. We're going to have all the same 5 steps, all the 4 or 5, all those steps. They're the same freaking steps. But let's talk about what's going to be different. Obviously, when I'm setting up my hypotheses, I'm not going to use mu. I'm going to use freaking p, right? Because we're talking about percentages, not means. Everybody with me so far? So that's one change. Who remembers what the second step is in a hypothesis test?
Determine if you're going to use t-scores or z-scores.
Yes, cool. And how do I determine that? What do I have to figure out? What's the most important thing to know if I'm going to do anything?
Normal distribution.
Good. So for an NPQ problem, because that's what this is going to be. I'm going to have a sample of size n. I'm going to have a p from that sample. I have a q. How do I determine if something's normal? I can't do no n greater than 30 bullshit, right? How do I check if a percentage problem is normal enough? What's the check? It's not n greater than 30. Does anyone remember? There's 2 things you have to check.
Someone said in the chat.
Oh, I'm sorry. There you go. Yeah. So I got to check NP and NQ. All right, so that's a change. So I got to use the right letter. I've got to do the right check for normality. Step 3 is the same. Jeff, what is... All right, let's try this again. There you go, buddy. Step 3 is the same. It's setting up the rejection region. That's not going to change. I got alpha. I look it up, blah, blah, blah. Oh, before I get too far, NPQ problems, I don't know what's going on, can only use z-scores or nothing. Why were t-scores invented? Somebody remind me, why were t-scores invented? Because some dude drank way too much Guinness. No, why were t-scores invented? I have to use them when what?
You don't have the... It's not standard deviation, is it?
It is. It's a specific kind.
Population
Sample.
standard deviation.
If you only have the sample one, if you don't have a population standard deviation, that's why t-scores were invented, to cover our ass for not knowing that. In an NPQ problem, we make our own standard deviation. We're always going to know it. We're always going to know the population. We're always going to know it. Square root of NPQ. So that's why NPQ problems, percentage problems, are z-scores or nothing. You never use a t-score with an NPQ problem.
Does nothing mean we can't complete the problem?
No, of course you can. Unless, I mean, there's always the possibility that you can't do anything for any kind of, if n is less than 30 and I don't know it's normal, I officially can't do anything. If NP or NQ or both are less than 5, I officially can't do anything, right? Okay, I like it. Hey, Mikey. Okay. Now, the big change, the biggest, holy shit. The biggest change, 5 is going to be the same. That's the conclusion. Who gives a shit, right? 4 is going to be probably the biggest change. What was 4 all about? 4 was all about Z star, right? Okay, so like the formula for Z star, I've never written this all the way out for us, so let me do it right now. Sure. That is the formula for Z star. Remember, we change the standard deviation, and then we do our data minus the middle divided by the new standard deviation. So that's what we do, correct? All right, now watch. All right, stay with me. This is so cool. And you guys are like, I don't trust you when you say that, because every time you say it, it's not cool, whatever we do. All right, shit. All right. This is kind of, might seem a little bit dumb, but which part of that statement, remember this? What is this equation for? What is that the equation for?
Intervals.
Yes, that's a confidence interval formula. I like it. And which piece of this tells me how big the spread is for that problem?
The error. Z.
No, because that includes Z, which is just the spread, which is just telling me the spread. Not, I'm trying not to use the word standard deviation because I mean, this is the spread here, right? That's the standard deviation of this problem, correct? For a confidence interval. You with me? Does that make sense? Is that cool so far? Maybe? All right, what I'm trying to get at is, can I use this formula for this kind of a problem? This formula for this problem? Am I going to have a mean? Am I going to have a mean? Am I going to have a standard deviation? Am I going to have any of that shit? No. Stay with me. When I'm doing a test of means, I want to see how far away a sample mean gets from a population mean, correct? I'm trying to see if it's far enough away. So for a P problem, I need the top of this to be a sample percentage minus the population percentage. What am I going to divide this shit by? What am I going to put down here? It's got to be whatever represents the spread. It's got to be whatever represents the spread. And what is the formula? What goes right here for confidence interval for percentages?
Is this all step 4?
I need you to understand. I'm explaining the idea behind what we do in step 4. So what we do in step 4 for means is this, correct? Correct? To figure out Z star, we do this for means. All right, now there's a lot of discussion going on, but this is what's important. I'm not going to be able to use this Z star formula. I'm going to have to use a different one. So all this is just figuring out what the shit this is. So what goes here? Does anyone recall?
PQ over N.
Yeah, and they had hats. They had hats because in a confidence interval, I don't know what P and Q are. In a hypothesis test, I'm going to assume I know what P is. So this is going to be hatless P, hatless Q over N. This must be the standard deviation. Do you guys agree with me? Isn't it in the right place to be a standard deviation? This is the standard deviation for this problem. So that's our new Z-score. This is a brand new formula, but not really. It's just sort of a Frankenstein's monster. We just pushed it in there and threw some lightning across it and was like, it's still dead. It's just ink on a, I'm sorry, getting a little weird today. So let's try a problem. So all that work I try to delineate the differences. And this step, I can't use this formula. I use this formula. That's it. Right? You don't have to do that. You don't have to do that. You don't have to do that. That's the end product. All right. So let's look at a handout, a worksheet. Actually, let me here. I'll be right back. All right, that was exciting. Ooh, where am I at? If you go to Canvas, let me make sure I've got this active. I think I do. All right, if you go to Canvas, all right, let me come back to modules. Ah, you doofus. Let me see. Here we go. All right, so if you go to modules, if you go to Unit 9. Oh, have I not done it yet? No. All right, hold on. Let me activate this. Why did you not activate this, Past Jeff? Leave me alone. All right, so now you should see one that says hypothesis practice percentages. So if you go into Canvas now, you might have to reload it if you're already in there. Refresh it. You should see this one about Chicago police up here. Okay. So I'm going to open this up in a different way. There we go. So we're going to do this first problem together, and then I'm going to let you guys do the next problem alone. So read through that problem. See if you can figure out what the claim is. Oh man, I was gonna say everybody I could see has left. and then is everybody still there? Are you guys out there? Can somebody tell me what the claim is? Well, there's Ethan, thank you. Anybody see what the claim is?
That 55% of Chicago residents have an unfavorable view of the local police.
Not quite.
At most 55%.
Yeah, all right, now change that into Mathish. That's too much English. Change it into Mathish. I helped you out. P
Is that greater or equal to 55%?
that would be at least 55%. At most is up to. All right. You guys with me out there? That is what at most looks like in inequality symbols. Because at most means up to, so less than or equal to. You guys okay out there? Anybody? Give me a thumbs up. Give me something. All right, I got
Give me
okay.
a thumbs up. My video's not on.
There's somebody partying. I love it. Just show me a sign of life. Can everybody show me a sign of life? Oh, Ryan's showing me some love. I love it. Oh, Melissa's even showing me a person. There's a person over there. All right. I'm sorry. I don't know if you guys can understand what it's like for a teacher, just not even being sure that you're really there. It just kind of sucks. Turn this on and go to my room, and when it's about time, I go out and log out. It's all good. I don't know. I'm not saying you do that. I'm saying some do, for sure. But which one is that going to go in for then? The ho or the, let me change this to a ha.
The ho.
The whole.
Yes, because it's got
An equals.
Now notice, please, dear God, we never use percentages. We change them to decimals right away, right? Now what's the ha going to be?
P is greater than 0.55.
Yeah. So what kind of test? How many tail tests will it be?
Just one.
One tail where?
To the right.
Up here. I love it because there the arrow is pointing you, right? Like Wasan said, I think. Okay. No. So is the distribution normal enough? What do I check?
If NP and NQ are
Good.
greater or equal to 5.
All right. So what is N?
$996.
Good. 996. And what's P? You don't have to do any work. No work.
594.
Wait, what? I'm sorry. Say it again.
594.
No, it's not a percentage.
0.55.
0.55. There you go.
Oh,
Hypothesis tests, we assume that the number we're working with is the actual population information.
so the P will represent the percentage mostly?
Has to be. Yeah, P is by definition a percentage.
Mhm.
P has to be less than 1, greater than 0. All right. And what is, I don't know, what the hell is that? What's about? Let's see, Jeff. 500, 50. So 543. I don't know.
547.8, so 548.
540. I'm not too far off. And that's at least 5. Check. And then I got to do N times Q. What's Q going to be?
0.45.
45. I like it. Q is where I get my information. No, stop. So what is N times Q? I believe it's going to be 448.
Yep.
Greater equal to 5. Check. So what does that mean?
It's normal enough.
Normal enough. So either it's normal enough and we use Z's, or it's not normal enough and we don't do anything.
So we're only able to use Z's because it's a percentage problem?
Yes, T-scores were invented specifically for situations where we're dealing with a mean and we don't know the population standard deviation. That's why they were invented. So they don't go with percentages at all. Or at least not in this type of process. Okay. I'll just say it. Well, not in stats 1. All right.
I have a question going back to part A.
Yes.
So will the HA like determine which side the one tail test would be on?
Every time. Yeah.
Okay.
This is the only one that could ever determine what the evidence, where the evidence would be, would need to show up. Does that make sense? I try to put that together on those fly. The ha is the only one that I can actually show evidence for. There we go. Because it doesn't have an equal sign. So it's going to be where what shows up where evidence needs to be.
Okay, thank you.
Sure. And again, it was a choice we made. We could have set up hypothesis tests completely differently, but we didn't. We set it up this way. Now, rejection region, level of significance 0.005. So it's a one-tail test. Alpha is 0.005. What's the critical region? What's the rejection region going to be defined by? What's z-score?
.4801. Oh wait, sorry, I'm looking at negative. .599, 5199.
No, you got to be careful. Is this a z-score?
Is it 2.576?
2.576. So again, this is a area. This is an area. Look at the t-score chart in the one tail row. 0.005. That's going to be the first column, right? Do you see what I'm talking about? On the t-score chart, first column, one tail, 0.005. Go all the way down because it's a z-score, and you should get 2.576.
I see it.
Sweet. So put it into words. If z star is what, we can do what?
Greater than 2.576, we can reject the null.
Good job, Joe. What is that? What the hell? Language. All right, sorry. Good Lord, Joe. We reject the null, and at the same time, we can also support the ha. I kind of missed the high, but too bad for me. Okay. See, so I told you, part C, exactly the same. Nothing different about part C at all, right? Exactly the same. Part A, the only difference is I got to use the right letter. Part B is quite a bit different, but it's still, I got to show it's normal. I just have to do it the right way. Now comes the big difference, part D. I still want to figure out what the Z star is, but I have to use the right formula for it, the one that's got percentages in it. Right, so N was 996. X is 594, the number of successes. So what is P hat?
.596.
Yes. So everybody with me? You just have to, what do we see in our sample? 594 out of 996. So that is 0.596. I like it. And now just take a minute, throw all that shit in there, see what you get for the Z star. Throw all that business in there. Wait.
What do we do for P?
We're assuming this is P.
Okay.
Same exact way. What do we put here for mu? We put the number from the hypotheses, right? We assumed that was the mean. Same thing we do here. What's the population percentage? We're going to assume it's 0.55. I like it. So the biggest mistake people make is they throw too many p hats and stuff in here. There's only one hatted letter, correct? I want one of you guys to describe statistics to a friend as, you know how algebra has variables? Well, statistics puts freaking hats on them. So have fun with that shit. All right. Sorry. So what goes here in the bottom? No, N is easy. There we go.
0.55 times 0.45.
Kick ass. Right, the only hatted one is this one. That's the only one you got from the sample. All right, let's see if you can all plug that in your old calculator. In your old calculator. I'll give you the first number so you know you might be on the right track. It should be 2 point something.
2.918.
9.2.
I like it. So if we put that in our picture, did we make it far enough away?
No.
Where's 2.92 in the picture? Where's 0 in this picture?
In the middle.
So where's 2.92?
Past the alpha.
In here. So let me ask this question again. Did we make it far enough away?
Oh, yes.
Yes, we're in there. We made it in. We made it far enough away. We found evidence. We found a sample that is so far away from 55% that it most likely is more than 55%. So we can reject the null, we can support the ha. Now, how am I going to write my conclusion? What language do I want to use? What was my claim? The ho or the ha?
The whole.
Good. So I don't want to use this language. I want to discuss the claim. I want to use this language. So we made it in there. We made it. So we have found sufficient evidence to reject the claim that what? Then you plagiarize, right? That at most 55% of Chicago residents have an unfavorable view of their local. Oh my God. That at most 55% of Chicagoans, is that what you call anybody from Chicago? Is it Chicagoans? I don't know. And most 50% have an unfavorable blah 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 view of okay, that's good. Would the police like this result?
Yes.
The police would like the result that it's more than 55% have an unfavorable view of them?
Oh, never mind.
Okay. So we rejected the claim that at most 55. So we've actually shown some evidence that it's more than 55. Yeah. I don't know. Some police probably would enjoy that. Like, I don't want anyone to like. I don't know. I'm not going to say anything about police. So now I want you guys to work on this problem on the next page. Oh, shoot. Somebody's chatting at me. Okay. Oh my gosh. All right, let me catch up to you guys. So this is obviously going to go there. It's got an equal sign. So then the ha is not equal to. So 1 or 2 tail?
2 tails.
2.
2. Good. Is it normal enough? Well, let's see. NP 322 times 0.845. What is that? I have no idea.
So the z-score would be 1.645.
Wait a minute. We're still in part B.
Oh, really? Oh, yeah.
So what's NP? Somebody help me out.
I got 272.09.
And that's at least 5. And then NQ. Q must be 0.155. right? So that P and Q together make 1. What do you get for that?
49.91.
And that's at least 5. Check! So we're allowed to use z-scores. We're allowed to do something, basically. All right, so now I know alpha's 0.10. I have a two-tailed test, and I can use z-scores. So when I look all that up, it sounds, holy crap. I'm going to leave it. That's a fantastic, look at that. That's a thing of beauty. It's, all right, sorry. So what, who said that earlier? What'd you get for the z-score again? It sounded like it was right, I think.
Yeah, 1.645.
Okay, that is correct. So if z star is
Greater than or
Negative
less
or
than.
positive, yeah.
well greater than 1.645 or less than negative 1.645. Be careful about trying to make things too efficient, or else you write something that doesn't make any sense. Right, greater than 1.645 or less than negative 1.645, because these are two totally separate regions. Then we can reject the hoe and support the one sarcastic laugh. Ah, okay. So now we've set up what the conditions are to find enough evidence. Now we go see if we found enough evidence. So N is 322. Was X 281? Is my brain working? 282, look how close I got. I got so close. So what's P hat?
0.876.
0.876, that is correct. Now let me give you a minute in case you haven't gotten here until right now. Go ahead and finish up that Z star. Don't say anything.
Could I ask a question?
Yes.
I'm having trouble trying to figure out if it will be one tail or two tail.
Whenever this is not equal to, that's automatically two tail.
Okay.
Because to show something does not equal something else, it could be bigger or smaller.
Oh, okay.
If this has a greater, that's one tail, one direction. If it has a less than, that's one direction down below, right?
Okay.
Like it. And I used to say not one direction the band, but I don't even know if you guys know One Direction. Are they still doing things? Or are they all done? Did they figure out what way to go and just went? All right, I'll stop.
They went into opposite directions.
Oh, they did? All right. That's what normally happens with most bands. They were like, one direction. No, this direction. No, that's all right. Well, screw this band then. So let me catch up to you guys. It'll be my data minus the one from here. Divided by square root of 0.845, 155, 322. Oh, shit. So let's see what we get here. This is a real easy one to get in the calculator wrong. I think I did it right. Oh. Let's see what you guys get.
I got 1.72.
Uh-oh, I didn't get that. Let's see, did I do something wrong?
About 1.54.
Yeah, that's what I got.
That's what I got at first, but then I thought the p hat, like since it's 0.876, that we had to that I had to like resubtract one from it again to get 1.24.
So you put, what'd you put right here?
I put p hat. Oh, I see, I messed up. Yeah, I see it, because that's what I got at first, and I thought I did it wrong.
Oh, okay. No, you did it perfectly.
Okay.
I don't think I've made this point very emphatically yet. Every hypothesis test we've ever done, we assume this is the real mean. And then we go see if we can find a contradiction. So have you ever heard somebody say, assuming you're right, look what he just did, right? Or whatever. Nobody can fly. Look at Harry. He's flying, right? So assuming you're right, how the shit's that going on? So that's what a hypothesis test is. Assuming this is right. So we're assuming that this is correct. And then we're going to go try to find evidence against that assumption. We're going to go try to find a contradiction. Did we find evidence against that? Did we make it far enough away?
No.
No, we only made it to right here. Right? We got right on the door. Oh, crap. That's my star. Oh, well. So we fail to reject. I keep forgetting to get the p-value, by the way. You got to go back and do it for the first one, too. Fail to support the ha. Can somebody figure out the p-value for this? You got to be a little careful because it's a two-tailed test, remember? How do you get the p-value for this thing?
Do you have to divide it by 2?
You have to multiply by 2. So you find the area in this tail that your z-star makes, and then you double it to make it fair to compare to alpha, because it's in both sides too. So look up 1.54. Make sure you adjust it so you get the area up in the tail that this thing makes, and then you have to double it.
So I look up 1.54 is 0.9382.
And that's of course the wrong area, right? That's the area below. So you got to do 1 minus that to get the area up here.
Okay, let me write. Yeah.
All right.
1 minus 9.3.
You guys get the same thing when you look up 1.54? You guys out there? Don't worry, we're gonna end class when we're done with this, because if I'm tired, you guys must be tired too. You're like, every day now it's the same thing, 5 steps, and blah. I'm like, all right, I know. I know.
1 minus that is 0.0618.
0618, that sounds right. Let's see. So to find the p-value, I would have to do twice 0.0618. For a two-tailed test, I have to double that to make it fair. So you get 0.1236. That's my p-value. Is that small?
No, that's kind of big.
Good. On the first day of this class, I think most of you guys would probably said that 12% was a small chance. We now know better. That is not unusual then, is it? So the smaller p is, the more evidence it is. And normally it's got to be below 5% or something, right? In this case, it has to be below 10% because this is a very forgiving, see right here? This is a very forgiving hypothesis test, but we still didn't even make it.
Is this standard? Like if we're just making an assumption, isn't the standard usually 5%?
That's the most often used one. But, and again, alpha actually doesn't exist in the real world. It's like everybody has their own level of evidence. That's all alpha is what level of evidence you need to be convinced. Does that make any sense? Alpha, like one person's alpha could be 0.10. And they're like, they're kind of easy. Another person could be 0.01. And they're like, I ain't going to be convinced until your sample gets way the shit out there. I don't trust you, right? I don't know if you guys are with me at all or not. It's not like somebody's walking around having an alpha on their forehead or something. But for each article they get, they have their own standard of evidence. When you're in class and you're learning this stuff, we give you alpha. We give you a level of evidence that's good enough because you haven't developed your own, because you haven't done this shit very much. I don't know if this is making any sense, so I'm sorry if it's not. So what the hell is our conclusion? Which one of these are we going to use to word our conclusion? What was our claim? Which one was our claim?
The hoe.
The hoe. So I'm going to use this language. I'm going to say screw this language. So we failed. We suck. We have not found sufficient evidence. That's what fail translates into. Good Lord, Jeff. Sure. 2, reject the claim. That I forget. 84.5% of professors, I'm sorry, where am I at? To reject the claim that the percentage of students, oh my God, there's so many words. The percentage of students who would agree that passing a 4-week stats course during the summer and retaining the information would be impressive. I don't know if I got everything in there. That 84.5% of students would agree with professors. Let's would agree with profs on this. There. It's too many words otherwise. Okay. Phew. That's where you go back and you can plagiarize and you can paraphrase. Your plagiarization can be paraphrased. Does anyone know the word paraphrase? No? That's the plagiarist's best friend, is try to paraphrase something so it sounds like it's your own words. Anyway. All right, guys. That's it. That's enough. We finished chapter 9. Chapter 9 is done. So next time we'll do chapter 10. And chapter 10 is the same stuff, except with an even bigger Z star formula. Yay! Sorry.
How exciting.
I think I'm really sorry. I'm in a goofy mood, man. I'm tired. But yeah, so we're done with chapter 9. We might do a little more practice next time. We'll see if you're up for it. We got chapter 10 to talk about. So we're right on track. We're doing pretty good. So go on, get out of here. Let me know if you need to hang out. Otherwise, you're free to go.
Have a good weekend.
Thank you.
Bye, guys.
Bye, thank you.
I'm going to show you a profile pic of my face when I heard that.
I'm sorry? What?
My face is pretty much a surprise Pikachu face when you said about that formula.
Oh, it's Pika? Yes, Pikachu. A big
Look
ass.
here.
Pika. All right. You guys good? Nikisha, you good? Okay. I'll see you later.